Interstellar objects are extremely rare guests in our solar system. They come from distant corners of the galaxy, cross its vastness, and for a brief moment become visible to our telescopes. 3 such objects that have received the most attention from astronomers in recent years are Oumuamua, the Borisov comet, and 3I Atlas. Each of them has its own discovery story, and together they offer a unique opportunity to compare interstellar visits to Earth. Fact: Oumuamua was discovered in October 2017 and immediately attracted attention with its unusual characteristics. The object trajectory did not fit standard models of comet and asteroid motion, and its shape, according to astronomers' estimates, was elongated and flat. The interpretation of these observations in the scientific community was that it was an interstellar asteroid, likely a fragment of a distant planetary system. However, some researchers suggested that the object might have had an artificial origin or be a spacecraft of an unknown civilization. There is speculation online that precisely the shape of Oumuamua, its unexpected brightness fluctuations, and the absence of a cometary tail could indicate the presence of an internal structure. Fact: the Borisov comet was discovered in August 2019 and quickly confirmed its interstellar origin using spectroscopic measurements. Interpretation: Borisov resembles traditional comets of the solar system, but its trajectory pointed to a different, extrasolar origin. Some researchers noted that its composition differed somewhat from classical comets. For example, the concentration of organic molecules and isotope ratios. There is an opinion that this may have been a sign of processes that occurred in its native system, but remain a mystery for our models. Fact: 3I Atlas was discovered in January 2025 and again surprised astronomers with its behavior and physical characteristics. Interpretation: similarity to classical comets on one hand, but dynamic anomalies in the tail and irregular emissions on the other. Some researchers believe that 3I Atlas may be a technologically modified object or even a deliberately directed interstellar visitor. According to certain indirect data, at the moments of peak activity, telescope data disappeared or became incomplete, which led to additional assumptions about hidden information. It is interesting to compare these 3 objects in terms of anomalies. Oumuamua had an unusual shape and brightness fluctuations, but did not show a classical cometary tail. Borisov looked more traditional, yet chemical differences left questions unanswered. Atlas, in turn, combines features of both predecessors: cometary activity, strange tails and emissions, as well as anomalies in trajectory and chemistry. Some researchers believe this indicates a certain common pattern that has not yet received a scientific explanation. Another fact: all 3 objects passed near the solar system at high speed, which makes their observation short and difficult. Interpretation: we see only a fragment of the picture, while the internal structure of these bodies remains hidden. There is speculation online that these brief appearances may be part of a larger galactic trail that these objects leave behind. Whether this is a natural coincidence or something more targeted is unknown. Moreover, in some satellite and ground-based images, observers noticed invisible shadows or dark areas around these objects, which quickly disappeared or were replaced with new frames. Fact: this is documented, although officially explained as optical artifacts. Some researchers assume that this may be a signal or trace of an internal structure that does not reveal its secrets. Thus, the first encounters with Oumuamua, Borisov, and Atlas create a unique context for analyzing interstellar objects. Whether these bodies are natural or hide a more complex, possibly artificial nature, remains an open question. There are many versions, and none of them has been disproven yet. Everything may turn out to be simpler, or, on the contrary, much more mysterious. One of the key aspects of comparing interstellar objects is their trajectory and speed. Oumuamua, Borisov, and 3I Atlas arrived in our solar system from different directions and with different velocities, giving astronomers a unique opportunity to observe interstellar bodies in action. Fact: Oumuamua traveled at a speed of about 26 kilometers per second relative to the Sun, and its trajectory was clearly hyperbolic, which confirmed its extrasolar origin. Interpretation: the object passed through the solar system only once and will not return. But some researchers noted that the trajectory had anomalous fluctuations that could not be explained solely by the influence of solar radiation or gravitational forces. There is an opinion that these fluctuations could have been caused by internal processes or even maneuvering, which is difficult to explain by natural factors. The Borisov comet moved slightly slower, at about 32 kilometers per second, and had a more typical cometary tail. Fact: its trajectory was also hyperbolic, confirming its interstellar origin. Interpretation: Borisov's behavior largely matched expected models of solar system comets. However, some researchers observed that its emissions and slight deviations from orbit looked too regular. There is speculation online that this could have been a sign of internal stabilization or controlled distribution of material. 3I Atlas traveled at about 28 kilometers per second, combining features of both previous objects. Fact: Atlas's trajectory was also hyperbolic, but small deviations and uneven gas emissions created additional difficulties for models. Interpretation: natural processes in the comet's nucleus could have caused these deviations, but some astronomers point out that the speed and direction of the emissions look coordinated, as if the object were regulating its own motion. According to certain indirect data, parts of telescope observations disappeared during monitoring, which led to further assumptions about hidden aspects of Atlas activity. Interestingly, all three objects showed different interactions with solar gravity. Oumuamua and Borisov behaved as classical models predict, but Atlas displayed short-term anomalies in speed and trajectory deviations. Fact: these anomalies were confirmed by several independent observatories. Interpretation: they may have arisen from uneven gas emissions, but some researchers allow the possibility that they could be signs of an internal control system within the object. Another point: the entry directions of the objects into the solar system differ greatly. Oumuamua came from the direction of the Leo stellar region, Borisov from nearly the opposite side, and Atlas with a complex trajectory resembling a curve that emphasizes its anomalies. There is speculation online that these directions are not accidental and may reflect a special pathway trail that these objects leave in the galaxy. Finally, all three bodies had a very short observation window, which makes accurate assessments even more difficult. Some spectra and radio data disappeared or became incomplete for no apparent reason. Access to part of the information was blocked literally within an hour, and official sources do not comment on it. Whether the trajectories of these interstellar travelers reflect only natural forces or conceal a more complex, possibly artificial scenario remains an open question. There are many versions, and none of them has been disproven yet. Everything may be simpler or much more mysterious. Comparison of the chemical composition and physical properties of Oumuamua, Borisov, and 3I Atlas makes it possible to understand how diverse interstellar objects are and whether common patterns can be found. Although all three objects arrived from distant regions of the galaxy, their structure and composition differ significantly, and some features appear anomalous, giving rise to suggestions about potential artificiality. Fact: Oumuamua, unlike classical comets, had no clearly visible cometary tail, although its shape was extremely elongated and flat. Interpretation: It may be a fragment of solid material or a hollow object that was once part of a planetary system. But some researchers suggest that the anomalous shape could indicate an artificial structure capable of withstanding interstellar travel. There is speculation online that the regular brightness fluctuations of Oumuamua cannot be explained simply by the rotation of a natural body. Perhaps the object is adjusting its orientation. Fact: the Borisov comet had a typical cometary tail, but its chemical composition turned out to be somewhat unusual. Interpretation: the isotope ratios and concentration of organic molecules do not match typical solar system comets. There is an opinion that this may indicate formation conditions in another stellar system, but some researchers allow for the possibility that the chemical properties could have been optimized by natural or even extranatural processes. Fact: 3I Atlas shows a combination of both types of behavior. It has cometary activity with tails and gas emissions, but at the same time exhibits anomalies in the speed and direction of these emissions. Interpretation: this may be the result of internal heterogeneity in the nucleus, but some researchers believe that such coordination of emissions and tail behavior resembles controlled activity. According to certain indirect data, during peak Atlas activity, part of the spectral and photometric data disappeared. Why unknown? Access to part of the information was blocked literally within an hour, and no official source comments on it. Another interesting fact: all three objects displayed differences in light reflection. Oumuamua had an extremely high albedo, Borisov a moderate one, and Atlas changed brightness with strange irregularity. Interpretation: this may indicate different surface densities and different minerals, but some astronomers suggest that changes in albedo could have been caused by internal modulation, which is difficult to explain by natural processes alone. Fact: Atlas spectra sometimes showed rare chemical lines that were not recorded in Borisov or Oumuamua. Interpretation: possibly short-lived chemical reactions in the nucleus. But there is speculation online that such spikes of activity look like signals or markers of the object's internal structure, which are hard to explain solely by natural laws. Finally, it is interesting that all three objects preserved their shape and composition during interaction with the Sun, despite their high speed and radiation conditions. Fact: they did not disintegrate and did not undergo catastrophic effects. Interpretation: this is a natural phenomenon, but some researchers suggest that such high stability may be the result of a structured internal architecture. Whether the similarities between Oumuamua, Borisov, and Atlas are accidental or hint at a certain hidden pattern remains an open question. There are many versions, and none have been disproven yet. Everything may be simpler or much more mysterious. Another important aspect of comparing Oumuamua, Borisov, and 3I Atlas is their tails, material emissions, and behavior while passing through the solar system. All three objects display distinct patterns, but it is the anomalies that raise the most questions among researchers and fuel conspiratorial assumptions. Fact: Oumuamua had no classical cometary tail, although its brightness fluctuated. Interpretation: this may be explained by a solid rock or hollow structure that does not allow gas to escape actively. Some researchers have noted that the regular brightness variations appear too systematic for a natural object. There is an opinion that this may indicate a controlled orientation of the object, leaving room for conspiratorial assumptions about an artificial nature. The Borisov comet had a typical tail of gas and dust, but its structure and behavior also raise questions. Fact: the material emissions were uneven, and some jets moved at strange angles. Interpretation: this may be natural activity of the nucleus, but some astronomers point out that the emission patterns seem too localized. Online, there is speculation that Borisov's tail may reflect some internal structure or process that we do not yet understand. 3. Atlas demonstrated even more unusual features. Fact: the comet's tail changed shape and density extremely quickly, sometimes literally within hours, and some dust jets moved at anomalously high speeds. Interpretation: this could be the result of uneven gas emissions or electromagnetic effects, but some researchers suggest that such changes look like controlled or purposeful processes. There is an opinion that the internal structure of the nucleus may direct the tail in certain directions. According to certain indirect data, during the peak tail activity of Atlas, part of the telescopic data became inaccessible. Why this happened is unknown. Access to part of the information was blocked literally within an hour. No official source comments on it. Some astronomers anonymously confirmed that they observed short-lived brightness spikes and structural changes that looked extremely organized. Another fact: infrared and spectral observations showed short bursts of heat in Atlas, even at a great distance from the Sun, where heating should have been minimal. Interpretation: these may be internal chemical reactions, but some researchers suggest that such bursts resemble signals or controlled events that seem to maintain the nucleus's activity at a certain level. It is also interesting to compare the directions of the tails. Oumuamua had no visible tail. Borisov had one that followed the object's general motion, while Atlas displayed strange deviations and local clumps that changed over short periods of time. Interpretation: this may be due to interactions with the solar wind and magnetic field. Some researchers allow that such behavior could hint at controlled activity of the object. Thus, the tails, emissions, and anomalies of Oumuamua, Borisov, and Atlas demonstrate both the natural diversity of interstellar bodies and mysterious features that leave room for conspiratorial assumptions. Whether these phenomena are natural or conceal something more complex remains an open question. There are many versions, and none have been disproven yet. Everything may be simpler or much more mysterious. Another key aspect for comparing interstellar objects is their speeds, trajectories, and motion anomalies. Oumuamua, Borisov, and 3I Atlas demonstrate interesting differences that place researchers before a difficult choice between natural and potentially artificial explanations. Fact: Oumuamua traveled at a speed of about 26 kilometers per second relative to the Sun, and its trajectory was clearly hyperbolic, confirming its extrasolar origin. Interpretation: the object passed through the solar system only once and will not return. But some researchers noted anomalous speed fluctuations that cannot be explained solely by solar radiation or gravitational forces. There is an opinion that these deviations may indicate internal activity or even adjustments to the object's trajectory. Online, there is speculation that Oumuamua may have been an observational or transport object, although there is no direct evidence of this. The Borisov comet moved slightly faster, about 32 kilometers per second, and had a more typical cometary tail. Fact: Borisov's trajectory was also hyperbolic, but the material emissions and slight motion deviations appeared too precise. Interpretation: such fluctuations can be explained by uneven gas emissions, yet some researchers allow that this might indicate internal stabilization of the object or the influence of unknown force factors. According to certain indirect data, observers noticed short-lived brightness bursts on some images that did not match classical models. 3I Atlas traveled at about 28 kilometers per second, demonstrating features of both previous objects. Fact: Atlas had a hyperbolic trajectory, but its velocity deviations and small jets of gas looked extremely coordinated. Interpretation: this may be a natural effect of uneven material emission, but some researchers believe that such behavior resembles controlled activity. At the same time, a weak electromagnetic field was recorded over the observation region, which cannot be explained by natural processes. Another fact: all three objects entered the solar system at different angles. Oumuamua arrived from the direction of the Leo stellar region, Borisov from almost the opposite side, and Atlas had a complex curved trajectory. Interpretation: these angles depend on interaction with solar gravity, but some researchers allow that this may reflect a certain galactic path of the objects. Whether this is a natural phenomenon or a trace of intelligent action is unknown. Fact: during observations of Atlas's trajectory, some telescope data suddenly disappeared or became incomplete. Access to part of the information was blocked literally within an hour, and no official source commented on it. Some anonymous observers confirmed that they saw strange signals and structures that were not published in open sources. It is also interesting that all three objects retained their integrity while traveling at high speed through the solar system. Fact: they did not break apart and did not undergo catastrophic effects from gravity or solar radiation. Interpretation: a natural phenomenon, but some researchers allow that this may indicate extraordinary strength or internal structuring that is difficult to explain by physics alone. Thus, the speed and trajectory anomalies of Oumuamua, Borisov, and Atlas create a space for assumptions and speculation. Whether all these deviations are merely natural coincidences or hint at a more complex, possibly artificial scenario remains an open question. There are many versions, and none of them have been disproven yet. Everything may be simpler, or, on the contrary, much more mysterious. Observations of interstellar objects are always limited by time, telescope availability, and weather conditions. Oumuamua, Borisov, and 3I Atlas demonstrate how difficult it is to study bodies moving at enormous speeds, and how even small gaps in data can generate mysteries and conspiratorial assumptions. Fact: Oumuamua was observed for only a few weeks while the object was visible from Earth. Interpretation: the short observation period limits the accuracy of estimating its trajectory, speed, and physical properties. Some researchers note that certain spectral data did not match between different observatories, which sparked assumptions about potential information concealment or technical artifacts. Online, there is speculation that the regular brightness fluctuations of Oumuamua may have been more complex than what appeared in public graphs. Borisov's comet was observed for longer, but even here there were gaps. Fact: some data from satellites and ground-based telescopes disappeared or became unavailable without explanation. Interpretation: this can be explained by technical limitations or weather conditions, but some researchers allow that this may have been filtering of information, especially regarding chemical characteristics and emission speeds. There is an opinion that Borisov may have had even stranger features that went unnoticed due to these gaps. 3I Atlas presents an even more complex picture. Fact: parts of photometric and spectral data disappeared during moments of peak activity. Interpretation: this may simply be coincidence or a technical problem, but some researchers believe such losses appear too systematic. At the same time, weak electromagnetic anomalies were recorded over the observation region, which are not explained by ordinary processes. Several observatory staff members anonymously confirmed seeing strange signals, though these data are not officially discussed. Another aspect: observation time. All three objects passed through the solar system over a very short period. Oumuamua, a few weeks; Borisov, about 2 months; Atlas, even less. Interpretation: the limited observation time makes it difficult to accurately determine the object's physical parameters and dynamics. Some researchers note that it was precisely during these short periods that anomalies in speed, emissions, and spectra appeared. There is an opinion that the full picture of these objects may differ greatly from what we see now. Interestingly, some satellite images showed dark zones or missing areas that were quickly replaced with new photos. Interpretation: these may be optical artifacts, but some researchers allow that these dark spots could have concealed important information about the object's structure or activity. Whether these gaps are accidental or part of a more complex scenario is unknown. Finally, all three objects maintained their integrity and did not break apart during interaction with the Sun. This allows their composition and properties to be studied. Interpretation: their internal structure may be much stronger or more organized than that of ordinary comets. Online, there is speculation that some details of their structure remain intentionally hidden due to data loss or filtering. Thus, the observations and missing information about Oumuamua, Borisov, and Atlas create an atmosphere of mystery. Whether all these gaps are accidental or conceal more complex facts about interstellar objects remains an open question. There are many versions, and none of them have been disproven yet. Everything may be simpler or much more mysterious. One of the most interesting topics in comparing Oumuamua, Borisov, and 3I Atlas is the possibility that some features of these objects may indicate an artificial origin or at least anomalous processes that are difficult to explain solely by natural laws. These assumptions, although unconfirmed, provide material for hypotheses and conspiratorial discussions. Fact: Oumuamua had an extremely elongated and flat shape, which is not typical for ordinary comets or asteroids. Interpretation: astronomers suggest that it may be a fragment of solid material or a hollow object. Some researchers note that its regular brightness fluctuations are not fully explained by rotation. There is an opinion that the shape and behavior of Oumuamua may be the result of a structured design capable of withstanding interstellar travel, or even of controlled orientation in space. Borisov's comet shows more natural features, but also has anomalies. Fact: its chemical composition and isotopic ratios differed from common comets of the solar system. Interpretation: this indicates formation in another stellar system, but some researchers allow that the unusual parameters may suggest optimization of the internal structure. Online, there is speculation that Borisov may have had properties that provided motion stability and controlled emission activity, although there is no direct evidence. 3I Atlas combines traits of both previous objects. Fact: it has an active tail and gas emissions, but it shows anomalies in the speed and direction of the tail's movement. Interpretation: this may be the result of uneven gas emissions or electromagnetic effects. Some researchers suggest this looks like controlled activity, as if the object regulates its own behavior. According to certain indirect data, during Atlas's peak activity, parts of the spectral and photometric data were lost. Why unknown? Access to some information was blocked literally within an hour, and no official source comments on it. Another interesting detail: all three objects maintained their structure while passing through the solar system. Fact: they did not break apart even at high speeds and during close approaches to the Sun. Interpretation: this can be explained by natural material strength, but some researchers allow that this indicates a structured internal build capable of withstanding extreme conditions. Online, there is speculation that some of the mysterious properties of these objects may have been hidden due to data loss or filtering. Another aspect: interaction with solar radiation and the magnetic field. Oumuamua, Borisov, and Atlas demonstrated various deviations from classical models. Interpretation: these may be natural effects, but some researchers believe the objects may have had their own stabilization or maneuvering mechanisms. Online, there is speculation that these features are not accidental and may conceal something unusual in their structure or activity. It is important to note that none of these objects has provided direct evidence of artificial origin. But the mysterious features, anomalous speeds, tails, and behavior of Oumuamua, Borisov, and Atlas leave room for speculation. Whether all these anomalies are merely natural coincidences or hint at a more complex scenario, that is for you to decide. There are many versions, and none of them have been disproven yet. Everything may be simpler or much more mysterious. Comparison of the interstellar objects Oumuamua, Borisov, and 3I Atlas makes it possible to draw several important conclusions, while also highlighting a huge amount of the unknown, which leaves room for hypotheses and conspiratorial assumptions. The characteristics of these objects show that although we have obtained a significant amount of data, the full picture of their nature remains unclear. Fact: all three objects had hyperbolic trajectories, indicating their extrasolar origin. Interpretation: they passed through the solar system only once and will not return. But some researchers note that the trajectories contain small anomalies that do not fit standard models of the gravitational influence of the Sun and planets. There is an opinion that these deviations could have resulted from internal activity or even subtle control of the objects. There is speculation online that some of these movements may be the result of anomalous forces that we cannot yet explain. Fact: Oumuamua was distinguished by an elongated shape and regular fluctuations in brightness. Interpretation: the natural explanation is hollow structure or the specific shape of a fragment. Some researchers allow that the regularity of these fluctuations appears too precise, which may hint at a certain structured internal makeup. Whether this is the result of a natural process or something more complex is left as an open question. The Borisov comet had a typical tail, but its chemical composition and isotopic ratios were unusual. Interpretation: this indicates formation in another stellar system. Some researchers propose that these features could indicate an optimized internal structure. There is speculation online that Borisov may have had properties that provide stability of motion and controlled activity of outgassing. 3I Atlas combines features of both Oumuamua and Borisov. Fact: Atlas shows anomalous outbursts of gas and dust, rapid changes in the shape of its tail, and brief bursts of heat. Interpretation: this may be a natural effect, but some researchers suggest it looks like controlled activity or a signal of internal structure. According to some indirect data, during the peak activity of Atlas, part of the spectral data was lost. Access to some information was blocked in literally an hour, and no official source comments on this. Another aspect is the preservation of the structure of the objects. Oumuamua, Borisov, and Atlas survived passing through the solar system, did not disintegrate, and did not lose significant mass. Interpretation: the natural explanation is the strength of material, but some researchers allow that this may indicate a structured internal build or the presence of anomalous properties that allow them to withstand extreme conditions. It is also important to mention the losses and gaps in the data. Telescopic observations lasted only a short time, and some data disappeared without explanation. Some anonymous observers confirmed that they saw strange signals or structures that were not published in open sources. Whether all these gaps are accidental or they hide complex facts is unknown. Thus, although we have learned a great deal about Oumuamua, Borisov, and 3I Atlas, their anomalies in shape, chemical composition, tails, velocities, and gaps in the data leave more questions than answers. Whether all these phenomena are natural or they hint at a more complex scenario, possibly artificial or controlled in origin, is up to you to decide. There are many versions, and none of them have been disproven so far. everything may be simpler or much more mysterious.